What a fine day for science!
If you think SpaceX designed first reusable rockets, then it's a big no. The space shuttle was the first vehicle developed to be reused. And trust me, this is a real engineering masterpiece. In this episode of Scientific Engineer, we will take a look at the development of space shuttle, its main components, and everything around it. Near the end of Apollo space program, NASA officials were looking at the future of American space program. At that time, rockets used to place astronauts and equipment in outer space were one-shot disposable rockets. What they needed was a reliable but less expensive rocket, perhaps one that was reusable. The idea of a reusable space shuttle that could launch like a rocket but deliver and land like an airplane was appealing and would be a great technical achievement further. The space shuttle was NASA's space transportation system. It carried astronauts and cargo to and from Earth's orbit. In the early development, a working orbiter was built to test the aerodynamic design, but not to enter into outer space. The orbiter was called Enterprise, after the Star Trek starship. So now you might ask, what did the space shuttle do? The space shuttle carried as many as 7 astronauts at a time to and from space. In all, 355 people flew on the shuttle. Some of them flew more than one time. During its history, the space shuttle flew many different types of missions. It launched satellites and served as orbiting science laboratory. On its later missions, the space shuttle was mostly used to work on the International Space Station. The space shuttle consists of the following major components. 2 solid rocket boosters or SRBs that provide most of the main force or thrust, about 71%, needed to lift the space shuttle off the launch pad. External fuel tank, which carries fuel for the launch, and orbiter, which carries astronauts and payloads. The orbiter has 3 main engines located in the backside of the fuselage. The main engines provide the remainder of the thrust, about 29%, to lift the shuttle off the pad and into the orbit. The engines burn liquid hydrogen and liquid oxygen, which are stored in external fuel tank or ET in short, at the ratio of 6:1. They draw liquid hydrogen and oxygen from the ET at an amazing rate of equivalent to emptying a family swimming pool in every 10 seconds. The fuel of the main engines is stored in the external tank. The ET is 48 meter long and has a diameter of 8.4 meters. The ET is made up of aluminium and aluminium composite materials. It has 2 separate tanks inside. The forward tank for the oxygen and the aft tank for the hydrogen, separated by an intertank region. Each tank has baffles to dampen the motion of fluid inside. The ET gets its signature orange color from the foam insulation sprayed on the tank's aluminium structure. The insulation helps the tank to act as a thermos bottle to keep the super cold propellants from evaporating too quickly. It also helps prevent ice from forming on the tank's exterior and promotes the right aerodynamic shape for launching into space. The 2 orbital maneuvering system engines are located in the pods on the aft section of the orbiter, one on either side of the tail. These engines are used to place the shuttle into final orbit, to change the shuttle's position from one orbit to another, and to slow the shuttle down for re-entry. The Space Shuttle Orbiter resembles an airplane in its design, with a standard looking fuselage and 2 double delta wings. There are 4 ailerons mounted at the trailing edges of the delta wings. Now one might ask, how did the space shuttle launch and land? The space shuttle took off like a rocket. The solid rocket boosters and the main engines on the orbiter provided the thrust, or the push, for launch. The solid rocket boosters burned for about 2 minutes, then the boosters dropped off from the shuttle and fell into the ocean. Special boats brought them back so they could be used again. The shuttle's main engine fired for another 6 minutes. The external tank dropped off of the orbiter, and at that point the shuttle and its crew are in orbit. In 1986, the Space Shuttle Challenger was destroyed in flight when a flame from a leaky joint on one of the solid rocket boosters ignited the fuel in external fuel tank. the Challenger exploded and the entire crew was lost. Once again, in 2003, Columbia was lost due to an impact by a piece of external tank foam on the port wing, which produced a hole large enough for a burn during re-entry. Discovery is at the Smithsonian's Stephen F. Udvar Hazy Center in Chantilly. Atlantis is at Kennedy Space Center's Visitor Complex in Florida, and the California Science Center in Los Angeles is Endeavour's new home. In 2004, US President George W. Bush announced that the space shuttles would be retired. The final flight came to a close when Atlantis touched down at Kennedy Space Center on July 21, 2011. A similar kind of reusable vehicle was developed by ISRO as a part of its technology demonstration. It was known as RLV-TD. It was successfully flight tested on May 23, 2016 from SDSC Shar Sriharikota, validating the critical technologies such as autonomous navigation, guidance and control, reusable thermal protection system, and re-entry mission management.
At the last, my latest, greatest work for the day is completed. Today was a fine day for science.
So, what do you think about our new video? Make sure to subscribe to our channel. See you in the next one. Happy sciencing!